Welcome to the Explainer. Today, we're diving into a really fascinating new algorithm, one that's inspired by something as simple as the wind, but it's designed to bring some serious order to our crazy digital world. Let's get right into it. So let's kick things off with a problem that, honestly, feels incredibly relevant to all of us: information overload. I mean, we are just swimming in this ocean of text data. You've got news articles, scientific papers, social media posts. How on earth can you get a machine to make sense of it all, to group similar documents together, without a person having to check every single thing? Well, the answer comes from this really cool area of AI called text clustering. The whole idea is to just let an algorithm sift through this mountain of information and, create its own logical piles. It puts all the medical stuff over here and all the articles about space over there, just by finding the hidden patterns inside the text itself. But as you can probably guess, this is way, way harder than it sounds. For years, in fact, clustering algorithms have been hitting two massive roadblocks that can just completely throw them off track. Okay, so first, you've got this thick fog. Every single document is packed with thousands of words, but most of them are just noise. Words like the, from, that tell you basically nothing about the actual topic. This is what's known as the curse of dimensionality. It's like trying to find a friend in a huge stadium by checking their shoe size and what they ate for breakfast. It's just useless info that slows you down. Then the second hurdle is this trap of a bad start. A lot of these methods literally just start by taking a wild guess about where the center of each topic group should be. And if that first guess is way off, well, the whole thing can be messed up from the get-go. And this is the thing, right? The older methods, things like particle swarm or harmony search, they really struggled with this. They were slow, they needed a ton of complicated fine-tuning, and even worse, they'd often get stuck on good enough answers, never finding the absolute best solution. It's like climbing a hill and thinking you've reached the top, but there's actually a much taller mountain right behind you that you never even saw. We clearly needed a better way. And that brings us to a genuine breakthrough, where researchers looked away from the computer code and found their inspiration in the natural world. They looked at the simple, elegant physics of wind. Air always flows from high-pressure zones to low-pressure ones. It's not thinking, it's just following this fundamental rule of nature, always looking for the calmest, most stable spot. And that led them to ask a brilliant question. What if an algorithm could do the exact same thing? What if it could treat bad solutions like high-pressure zones and just naturally flow towards the one single best solution, the point of lowest pressure? And here's how that amazing idea actually works. The new method is called wind-driven optimization, or WDO. It basically creates a bunch of potential solutions, and it treats each one like a tiny air parcel. Then each of these parcels gets a pressure value. The worse the solution, the higher the pressure. And after that, the algorithm just lets physics take over, moving the high-pressure parcels towards the low-pressure ones until they all gather together in the calmest spot, which is the optimal answer. So how does this win actually solve our two big problems, that fog of words and the trap of a bad start? Well, this is the really clever part. It's a two-step process that uses the same idea to knock them both out. First, they use the algorithm as something called a feature selector. You can literally picture this as a powerful gust of wind that just blows away all that fog we were talking about, all those useless, noisy words. It leaves behind only the most important terms that actually define what a document is about. Think of it like this license here on the screen. Its whole purpose is to strip away all the legal jargon and get to the absolute core of what you can and can't do. WFOS does the same thing. It strips away all the noisy, irrelevant words to get to the core meaning of a document. It's all about focusing on what is absolutely critical. Okay, so now with all that noise gone, the data is way cleaner. So they apply that same wind-driven logic a second time, this time for the actual clustering part. And because it's working with such clear, simple data now, the algorithm can intelligently find the best centers for each topic group right from the start. That bad first guess trap? Completely avoided. All right, this all sounds incredibly cool. But does this whole two-step nature-inspired thing actually work in the real world? Let's get to the results, because this is where it gets really exciting.
First off, just look at this number, because the result of that first step alone is just staggering. That gust of wind, it successfully blew away more than 50% of the words from the datasets. I mean, it literally cut the complexity of the problem in half before the real sorting even began. That's like cleaning your entire room before you try to organize it. It just makes everything else so much easier.
And that cleanup had a massive payoff. As you can see right here, the combined WDO approach hit a performance score of 98.3%. This didn't just beat the old-school algorithms, it completely left them in the dust. While the old methods were stuck down in the high 80s, WDO was basically nearing perfection. That is a huge leap forward. And to make sure this wasn't just some lucky fluke, they put all the algorithms through this intense head-to-head competition, ranking their performance across a bunch of different tests. The results here are just undeniable. The full two-step WDO approach finished in first place. It proved it's not just better, it is consistently the most effective and reliable method of the whole bunch. So, what's the big takeaway here? This isn't just some small improvement on an old idea. This is a real shift, a move away from complicated brute force math and toward elegant, nature-inspired problem solving. By using one simple concept from physics, this whole approach solves two huge problems at once, giving us a tool that's more accurate, more efficient, and way more reliable for finding meaning in our world of digital chaos. And this leaves us with a really fascinating final thought. If the simple physics of the wind can so elegantly solve a complex data problem, what other secrets is nature holding? I mean, what could we learn from the way a river carves a canyon, or the way a forest communicates, or even the way stars form in a galaxy? The next great algorithm might just be waiting for us right outside the window.